All right, you guys, so today, last lesson in this chapter, 9-7, independent and dependent events. Today is 2/23/18, so get that down, please. You have a quiz on Monday, so today's homework will actually be on Tuesday. It'll be due on Tuesday, okay? You have a quiz on Monday on 9-4 to 9-6, so make sure you prepare. How do you prepare? By doing odd questions, and you can go back and watch the videos if you didn't understand one of those lessons. Okay, that's the neat thing. And I've gone and looked at the number of views, and there aren't that many views. So that tells me that you're either getting it or not a lot of people are missing anymore. Okay, so having said that, 9-7, independent and dependent events is our title. Go ahead and put it down, please. Can you believe it?
Like someone
Give
from
me your
Benjamin.
beard.
No, he doesn't have a beard. He's too young to have a beard.
Just the
He
rest
looks like
of
someone
the
you need to give
Benjamin.
him a body next time.
Okay,
He's
you guys, every time we talk about this, you guys relax. Thank you. I know it's exciting to see BuzzFeed evolving, but all right, here we go. Independent events. What is the difference between independent and dependent events? Okay, so let's have a look at this and see what we're doing. Everybody please pay attention. Not drawing on your airplanes. Thank you. For lunch, Jessica may choose from a turkey sandwich, a tuna sandwich, remember you're writing this down, a salad, or a soup. For a drink, she can choose juice, milk, or water. If she chooses a lunch at random, what is the probability that she chooses a sandwich of either kind and juice? That's the question. Write it down, please. So I want you to understand that this would be called an independent event because you're choosing, first of all, from a type of sandwich, type of food to eat basically, whether it's a turkey sandwich, a tuna sandwich, a salad, or a soup. It's independent of what you choose as a drink, okay? So the drink would be either juice, milk, or water, okay? So this is an independent event, meaning they don't have anything to do with one another. They're independent of one another. Okay? That's what that means. That's a good way to think about independent. A dependent event would be like if you pulled a marble out, there was 20 marbles, you pulled out one marble, and then you put it back in. Okay? Then, or if you pulled one marble out, you didn't put it back in, then the next thing would actually be only 19 marbles starting with 20, so that would be dependent on the other one. But we'll talk a little bit about more of that as we get to dependent events. The first one right now is an independent event though. And I'll try to explain it a little bit more once we see both examples. I think it'll be easier for you to understand. Okay? So we're choosing it at random. So how many choices are there for food up here? Oscar?
4.
4. You can get a turkey sandwich, a tuna sandwich, a salad, or a soup, okay? And how many choices are there for the drink, Gemsley?
3.
3. So how many total choices would there be if we used the fundamental counting principle? Blaine? 12. 4 times 3, right? Now, it's asking you, what is the probability of choosing a sandwich of either kind and juice? So there's 2 types of sandwiches, right?
Yep.
And then there's juice. 1 juice, right? So instead of using the fundamental counting principle, we're going to do something a little bit different. So pay attention and watch this. Okay, so first of all, we have to find out what the probability of getting a sandwich is. Well, getting a sandwich is 2 out of 4 or 1 out of 2. Agreed?
Yes.
Okay, so we write that down first. Probability of a sandwich equals 1 out of 2. And then we find out the probability of getting juice is 1 out of 3. Right?
Yeah.
There's juice, milk, or water, and juice is 1 out of 3. So you have these 2 things, and they're independent events, so all you have to do is multiply them. 1 times 1 is 1. 2 times 3 is 6. So the probability of getting those would be 1 out of 6. Now if we would have done it the other way and kept this as 2 over 4, you would have got 2 over 12, but then you would simplify it, right? To 1 over 6. So you could do it that way as well, and you'd have to simplify at the end. But sometimes it's easier to simplify at the beginning, and you're working with smaller numbers. Yes, Jake?
How do you know when the probabilities are independent?
Because they have nothing to do with one another. They're independent of each other. You can go and pick a sandwich or a food without even thinking about the drinks. Okay, now that the food is picked, now you go to another section in the restaurant and you go and pick your drink. It's like they're independent of each other, right? If it was, you had to pick out of 6 different types of sandwiches, then they wouldn't be independent of each other, right? But you have to have 2 of them, so you multiply it and you get your answer. Okay? I think you'll have a better understanding once we see what a dependent event is. So let's look at your turn. You don't have to write this down, but let's see if we can do this. Okay? Paying attention, Michael? Thank you. Let's look and see if we can do this. I'm going to ask you to raise your head off of there. Thank you. And then, nope. And then, yeah, if you didn't get it all down, you need to get it from somebody else. There's more than enough time to get it down. Zachary has a blue, a red, a gray, and a white sweatshirt. Okay? So that's 1, 2, 3, 4 different types of sweatshirts or colors. He also has blue, red, and gray sweatpants. Okay, so that's 3 different types of sweatpants. If he randomly, first of all, pulls a sweatshirt, and then he pulls a pair of sweatpants, what is the probability that they will both be blue? So let's figure out the first one. The probability of a blue sweatshirt is 1/4. Okay? Excuse me. Raise your hand if you think you know the answer. So the probability of the blue sweatshirt, and I'll just put SS sweatshirt, is 1 out of 4. And the probability of blue sweatpants, and I'll put SW, whoops, no I wouldn't, sweatpants, how's that SW? SP, okay, and that one is, how many are blue? 1 out of 3. So we take these 2 numbers, 1 over 4 times 1 out of 3, and we get 1 over 12. So the probability of that happening would be 1 out of 12. Yes, Oscar?
Isn't this similar to like theoretical
Is this similar to what?
probability?
is similar in that you're finding a probability of each one, but now you have to multiply them together. So independent events you multiply together. Let's find out now what we do with dependent events. Okay? Okay, everybody ready? Okay. Thank you for saying no. I'll wait 30 seconds and then you should get this down. Remember, you're not writing this whole thing down, you're just writing how to do it, because you've already got the first example written down. And again, if you ever miss an example, number one, it's on YouTube, but number two, you can get it from somebody in class. Okay? And your notes are worth 10% of your grade, so you definitely want to do something about that. Okay, so this is the next one. This is one you have to write down. It's the last long thing you have to write down. You don't have to write down committee selection, but you do have to write this down right now so I don't have to wait for you. Mrs. Tierney, you're writing this down now, will select 2 students from her class to be on the principal's committee. She places the name of each student in a bag and selects one at a time. The class contains 15 girls and 12 boys. Michael, you're supposed to be writing this down.
Thank you.
What is the probability she selects a girl's name first, then a boy's name? Write it down now. Unless you'd like to come here after school and write it down. Let's go. Yeah, this is the last thing. Choices in this world, huh? Making good choices, good consequences. Bad choices, bad consequences. Keep that in mind. Because the good news is, another minute to write it down, so I've given you like 3 minutes to write the, 3 sentences down, maybe 4 sentences down. You can't handle that, you guys? You're gonna have to wake up, because this is minor. Back in my day when I walked through snow this high to get to school, we used to take notes the whole class. And guess what? The teacher would speak and we would have to take down the notes of what he was speaking. Or she was speaking. So if you think this is tough, Mrs. Tierney will select 2 students from her class to be on the principal's committee. She places the name of each student in a bag and selects one at a time. These are dependent on each other, because once you select one student's name, you can't put it back in, exactly. And it will tell you. If you get to put it back in, then it is not dependent. Then it becomes independent. But right now, as soon as I pull out one of these girls or one of these boys, it goes from being 27 names in the bag to 26. Agreed? Yeah. Okay. That's why it's dependent. Okay, so you see it? Me pulling out from the same bag makes it dependent. Me choosing a type of food and then a type of drink is independent. So what does this look like? Pulling the girl's name first is 15 out of 27. Okay? So it says, what is the probability she selects a girl's name first, then a boy's name? So we have 15 out of 27. When she's first pulling out, she has 27 choices, right? 12 plus 15 is 27. But now, one of the girls' names is gone, so now there are only 26 boys' names, but there's still 12 of them in there. There's 26 boys and girls' names, but only 12 of them are boys, because one of the girls is gone. If you want to right now, simplify it you can to 6 over 13. So there's two different numbers here, 15 over 27 and 12 over 26, which is 6 over 13. It's okay to simplify it, it'll just make it easier to work with those numbers. And now what you do with those numbers, and I'll go back in a moment, is you multiply them, okay? So here they are, 15 over 27 times 6 over 13. Remember that if you can cross reduce when there's fractions and you're multiplying, it makes it easier. Or you can just multiply across, get a big number, and then divide the top and bottom by 3. You could have also done that right here. Divide this by 3 and it's 2. Divide this by 3 and it's 9, right? Then 9 times 13 and 15 times 2. Oh, they did cross reduce it. Yeah, that's a really interesting thing. Oh, they did cross reduce it. Okay, that's how they got 30. I was gonna say, wait a minute. Okay, they did cross reduce it. So 15 times 2 is 30. 9 times 13 is 117. Well, at this point, guess what, you guys? It can still be divisible by 3. And how did they do that? Using the cake method. Always at the end, you want to check to see if the cake method, anything goes into it. So it's 10 out of 39. Do I need to go back one slide to? Okay.
I have a question.
Okay.
We took one and
No, I'm going back to the one slide. There it is. I'll move to that one next. Yes, Mikey.
Is there any other way to do it besides cross multiplying?
Multiply across, and then simplify at the end. No, it's not actually, because you're working with bigger numbers. Cross multiplying is easier because you're working with smaller numbers. So we only have a couple of minutes left. I'm going to put the homework on the board, and then I'll let you do the your turn. I know there's a couple of people that need to write this down. You have like 30 seconds, get it down. Some people chose not to write anything for the first 2.5 minutes, and that wasn't a good choice. So your homework is page 400, I think.
Page 400.
The second, please, quiet. Yeah. Page 400. Excuse me.
7 to 7.
See, originally, this was going to be, yeah, you're doing 6 to 16, number 6 to 16.
No, I
Excuse me, number 6 to 16 all. On page 400. So you have the girls' first name, 15 out of 27. You have the boys, 6 out of 13. You move forward. 15 over 27 times 6 over 13. You cross reduce. And you get 10 over 39. What happens when you make choices not to write down things right away.
Some people are really slow.
Okay? And here's your turn. Okay, please pay attention. 15 glazed donuts, 9 jelly. She selects 2 donuts, one at a time. Okay, so we have 15 glazed and 9 jelly. What is the probability she selects a jelly and then a glazed? So jelly and then a glazed is the order that we want it in. So getting the jelly, there are 9 jelly out of a total of 24. And then once one of them is gone, there's only 23 left. And the next one is 15 glazed, okay? So basically we take 9 over 24 and multiply it by 15 over 23. Can we cross reduce anywhere on this one? I think that these could be simplified, right? 9 over 24. 3 goes into both those numbers, does it? Yeah. 3 over 8, right? That makes it easier. 3 times 15 is 45. And 23 times 8 is 184. Did I make a mistake?
No, you could cross reduce
The 8 and the 15?
no, you no.
45 over 184. Okay, so that was your turn. I know that a couple of you wanted me to go back on the slide, so is it to that one? Juliana, do you need one more still, or
We need the first one.
this one? So, you guys, the next one?
No, the first one.
Oh no, not right now. Everybody got, okay, so then you need the first one.